start
Okay.
for now?
Yeah, I think we can start it. Hello everyone. My name is Frank Yan, and today's speaker is Henry, a data scientist at Merck Pharma Japan since 2019, with a master's in neurosciences. So Henry will show us how to use R and graph database to build a doctor activity network using diverse data. So please join me in welcoming Henry. Thank you.
Thank you very much. Let me try to go full screen. Okay. So, hey everyone. So, as Frank presented me, so my name is Henry. I'm working at Merck Biopharma Japan, the Merck that is currently headquartered in Germany. And right now at Merck, we are a team of 5 data analysts, and we are mainly using R in our day-to-day activities for basic reports, some machine learning activities with the very good tidy model package, and also to design new tools or new way to manipulate the data. We also do a bit of Python, but this right now is mainly for the AI machine learning kind of activities, notably everything that is linked to the large language model. But the few packages for R are coming as well. So now a bit of background. As you have probably all of you have seen, we've got a lot of requests coming like from other departments, commercial department, about new way to reach our customer. You will hear things like omni-channel, how to leverage digital channel, digital activity, maybe a bit of macro targeting, all these kind of things. What it concretely means for us, it means how can we exploit the data being currently available? How can we like find new relations between data? Or how can we integrate new data sets into our system in a way that is easy to do and also easy to find new actionable insights? Now let's look at a bit more concrete example. Let's say that someone from your marketing teams is coming to you with a questions. Oh, I would like to get a list of the HTTP that graduated from the same university as the next event speaker. Maybe like we want to target them in a bit different way. If we take these questions and try to answer it by pulling data from like a more traditional database, so the relationship database management system, then it's fairly complex. You got a few different view from the database, and you have to join them with the join statement in SQL. So it gets complex fairly fast, even for what looks to be like a fairly simple questions. And also it gets slow very fast as well. So it's possible, but it's not really the best way to do these kind of things. Now, there's a better way to do it. And this is where this graph database structure are coming in. Fundamentally, a graph database is just a very efficient way to represent, store, and query a relationship. So what you can see on the left, it's the basic foundation block of a graph database. So you got a series of nodes, for example, here, the HTTP or an event, which are basically single entities. And each nodes will be linked to each other by an edge or relation. And when you want to query this specific relation, for example, you want to see this, you use a language called Cypher, which is very similar to SQL, but a lot more efficient when you want to simply see a relationship. So for example, you got HTTP Spokat events. Right now, if you want to use this kind of database structure, there's two, I would say, like main tool being available, which would be memgraph and Neo4j. So now if we go back to previous questions, but try to answer it with a database, what you can see here is that from the get-go, all the relationships that we're looking for, they are already baked in the model. It's already present. What it means in the end is that it's a lot easy to query. The query is a lot simpler to write, but that's so a lot faster to query. It will get a big jump in performance. And here you can see, for example, an example of how we query these kind of questions. And simply you just say event, Spokat, HTTP, graduated, university, and so on. It's very, very like intuitive way to query this kind of relation. So now, how do we go about creating this kind of network? So we start, as all things start, with a more traditional database. And then we will build a package and a series of functions with this package that will take our data from this database and then transform it into CSV file that can be understood by memgraph in our use case. And then with some statement called Cypher, we'll just export it to memgraph and then can build our database. If we start with our R package, so we decided to go with an R package because right now we already got a list of functions that all our team is currently using in a way to just automate and standardize the way we just access all this kind of data. So based on this, it was simply a lot easier to just reuse our current processes and add new functions that will help us to create this new file that we can use for our package. And also, because we are a team of 5 developers, combining this package made with DevTool, Tesat, and Oxygen, we can also get a very strongly unit test system to make sure that everything is fairly robust, even if we add new functions into it. Once we got this package being done, it's simply just to run these functions on a day-to-day basis, get this output, export them to memgraph, and then we got our new applications being ready to use for other things. And this is a very good tool if you want to do something like macro targeting, or even leverage some more AI applications. Or what we are currently doing right now is to make some recommendations to our commercial teams with what we call the next best action system. So how do we go about creating this kind of specific CSV file? So in the case of a node, for example, you can see here the node that I showed previously. It's in the end just simply a label and then a list of properties. If we want to look how it looks like within a CSV file, it will be one unique ID and then the series of properties, which we need to combine with a Cypher query to add the label at the end for the network to work. To create this CSV file, this is where we'll use our package and our new functions to convert from our more traditional database system to this new node. So you can see some fairly basic kind of functions when we just put up our attendance data or HTTP master data, joining everything together, and then we get this output. Add this a few unit tests to make sure that the ID are unique or you don't have any NAs or unexpected data, and you get something fairly robust. Now, if you want to build some relationship, it's a very similar process. So this is how a relationship look like. So you got a node where you start from, then your relationship that is described here, and then the output nodes. Within a CSV file, it will look like this. First node with a unique ID, then the second node, and the list of properties of this relationship. Add this another Cypher query, and then you got your relationship being ready to be queried. And to build it, same process before, within our package, we get a specific functions that we just call the previous function that we have defined to create the nodes. So get speaker node, get event nodes. Then on top of this, another functions here that we just pull within our RDBMS the link between event and attendance, merge everything together, and then we got this CSV file that we can use. Once we got all these CSV file, we will just export them to memgraph using the Cypher queries. And this query just looks simply like this. So just load your CSV file, then just create the actual content of a node. So the label and every properties that you want to add. For relationship, it's a very similar process. You just import your CSV file and then define where you start from, when you end up at, and then how it will look like. Once you have done this, you can repeat for every node relationship. You end up with your network being done. And with this system, you can see it's very easy to just take data from let's say your acting department just buy some new data. You can just take the file, simply write a few functions to transform it to a format that is accepted by this language system, and then export it to network and just expand your network like this. Now, maybe an example of how do we actually use this right now. So we got our database that is linked to our CRM. Then all of this other what we call floating files everywhere, but like every team is buying like data a bit everywhere, that we just store in S3. Within a function that we made with our own package, we process everything, create a list of CSV file, each CSV file being either a node or relationship between two nodes, and then add some Cypher statements to export everything into this final network. So right now, what you can see, this is a prototype of what we call our Doctor network, which is basically like a HTTP-centric network in which we want to connect as many data points as we have to an HTTP. Like this, when we want to make some next best action system, for example, we can very easily like see relationship and then write some query that will help us make some recommendations to our salespeople or MR and so on. And if new data is bought, it's fairly easy to just add a new relationship to this and then add this to our queries that we just run on a day-to-day basis. So that's most of what I wanted to present to you today. I don't know if there's a few questions that I can answer for now.
Thank you, Henry. It's an amazing talk. Any questions to Henry? Oh, Daniel asked about MBJ data is public.
No, that's actually a package that we're making internally to query our own database system, but it's something like that. I think it's fairly easy to produce.
And oh, there's another question. Is there any way we can get an HCP data set?
HTTP dataset from web links. So the HTTP actually refers to the healthcare professional. So I'm expecting that if you got access to your own CRM, you can just pull like a master data of your healthcare professional that work within your countries and then just add it from here.
Did the HCPs require training to use the infrastructure
So
from them?
yeah, actually, this HTTPs right now, this is the doctor, but maybe like you mean the MR or the marketing team. And this is actually like some issue that we got right now. And the way we think this is that we'll do like two approach for this. One will be is that we just design some use case and just share with the output to the MR or the marketing team. But also we're looking for a way to develop a chatbot interface that will leverage large language model and then the function calling to just simply query the network like this. So the marketing team can just ask the questions that will be transformed to a Cypher query and then get the output from this.